Welcome back to the second video on More SQL. This is part of our series of lectures on relational databases based upon the textbook Fundamentals of Database Systems by El Masri and Navath. We're going to pick up with our lecture at that point. SQL allows the use of tuples of values and comparisons by placing them in parentheses. This query will select the ESSNs of all employees who work the same project hours combination on some projects that employee John Smith, whose social security number is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, works on. In this example, the N operator compares the subtuple of values in parentheses. Here is your query in parentheses that represents the subtuple of values. Project numbers and hours within each tuple in the works on table with the set of type compatible tuples produced by the nested query. Take a look at this. Select distinct ESSN. And we recall from a previous lecture that the distinct clause is used to prevent duplicates from works on table where project number, comma, hours in, so that's pulling out of a range of values, and it's used in another select query to retrieve that range of values, and it is selecting project no and hours, same attributes that you see in the where statement over here, from works on where the employee social security number is 1, 2, 3, 4, 5, 6, 7, 8, 9, which would have been Mr. Smith. Let's take a look at this query. We're asking for the employee numbers, ESSN, I assume is the employee number, from the works on table, where the project number and hours are the same as the project number and hours in works on of Mr. Smith. In addition to the N operator, a number of other comparison operators can be used to compare a single value, typically an attribute name, to a set or multi-set, typically a nested query. The equal any or equal sum operators return true if the value is equal to some value in the set and is therefore equivalent to n. The two keywords any and sum have the same effect. Other operators can be combined with any or some, including the greater than equal to, less than equal to, and of course the not equal to. The keyword all can also be combined with each of these operators. Let's say we're using a variable V to represent a single attribute, and we're using a variable capital V to represent a set. And we use the comparison condition, open paren, V is greater than all capital V, close paren. This will return true if the value of V is greater than all the values in that set or capital V. An example is this query, which returns the names of the employees whose salary is greater than the salary of all the employees in Department 5. Select last name, first name from employee where salary greater than all. Then we open up another select statement, select salary from employee where department no equals 5, close paren. So this query will give us a list of all the employees who make more money than everybody from this query. In general, we can have several levels of nested queries. We can once again be faced with the possible ambiguity among attribute names if attributes of the same name exist, one in a relation in the from clause of the outer query and another in the relation in the from clause of the nested query. The rule is that a reference to an unqualified attribute refers to the relation declared in the innermost nested query. For example, in the select clause and the where clause of the first nested query in Q4A. Let's back up to Q4A and take a look at it. Here it is. A reference to any unqualified attribute of the project relation refers to the project relation specified in the from clause of the nested query. Here's the project relation. Here is another project relation. This is the attribute being referred to in this query. To refer to an attribute of the project relation specified in the outer query, we specify and refer to an alias, a tuple variable, for that relation. These rules are similar to scope rules for program variables in most programming languages that allow nested procedures and functions. To illustrate the potential ambiguity of attribute names in nested query, consider this one. Retrieve the name of each employee who has a dependent with the same first name and is the same sex as the employee. And in this query, we're selecting e.fname and e.lname, so we've qualified those two attributes with an alias for the employee name from employee as e, that's where the alias was defined, where e.ssn is in, open print, another query, a nested query, which is selecting the ESSN from the dependent table, which is also being assigned an alias of D, where e.fname equals d.dependent name and e.sex equals d.sex. Now, without these qualified attributes, how would SQL understand where fname equals dependent name and sex equals sex? So to avoid these potential errors and ambiguities, it is advisable to use aliases to refer to these tables. Whenever a condition in a where clause of a nested query references some attribute of a relation declared in an outer query, the two queries are said to be correlated. We can understand a correlated query better by considering that the nested query is evaluated once for each tuple or combination of tuples in the outer query. For example, we can think of Q16 as follows. Let's back up and take a look at Q16. If the SSN of the employee tuple is in the result of the nested query, then select that employee tuple. In general, a query written with nested select from where clauses and using the equal or in comparison operators can always be expressed in a single block query. For example, this Q16 can be written as Q16A. None of the nested queries in this one. The exist function in SQL is used to check whether the result of a correlated nested query is empty, that is, contains no tuples, or not. The result of the exist is a Boolean value true if the nested query result contains at least one tuple, or false if the nested query result contains no tuples. We illustrate the use of exists and not exists with some examples. First, we formulate query 16 in an alternative form that uses exist, as in Q16b. Exist and not exist are typically used in conjunction with a correlated nested query. In Q6, the correlated nested query retrieves all dependent tuples related to a particular employee tuple. If none exist, the employee tuple is selected because the where clause condition will evaluate to true in this case. We can explain Q6 as follows. The query request: retrieve the names of employees who have no dependents. For each employee tuple, The correlated nested query selects all dependent tuples whose ESSN value matches the employee social security number. If the result is empty, no dependents are related to the employees. So we select that employee tuple and retrieve its F name and L name. Well, that's quite a bit of material in this video, so why don't we call it an end to this one. We haven't selected a mystery word, so let's use exist as our mystery word. Go ahead and submit it. Go out to check your knowledge on the material covered in this video. And when you're ready, come on back and we will continue with video number 3 in the discussion on More SQL.